All right, so we are going to kind of go through all the topics as you will see how I'm going to teach. So I'll actually click on the thing and look at the topics and go through what I find necessary to tell you in class. Not necessarily I'm going to cover everything that is in here. It's your responsibility. We are not, it's college, so you need to go through this. So I'll go through all the things that I see in here, and I see it's necessary for me to kind of carry the point. And then you go and study, and if there is anything you feel it's not understood, the next day you're coming with questions. If you need explanation, I'll take you through it. If not, then you understand what's going on. And also, depending on questions that in class is asked, and also the need for it, I may tell you stuff that are not in the notes. Something that I find it necessary, especially like when we go to the end of the semester, I'll prepare you for OOP244, and doing so, I'm going to teach you stuff that are not in here, so you can have a strong start for your OOP244. So we talked about object orientation. We said there are three pillars of object orientation, and as you see, the microphone is here. Now, the further you sit beside from each other, the longer you have to walk and give that microphone to someone else. So next time, please don't get scattered. Get closer to the screen so we can actually pass it. Actually, I'll give it to the people. Don't worry about it. Okay, so the reason is you listen to the recordings, you're going to see that you're going to only hear me talking, and the person who's asking a question somewhere, they're not heard. So it's a good idea to have that second microphone for that. So why we are learning object orientation? It's a very simple and straightforward thing, learning object orientation. Why do we need to learn it? The reason is that no matter how organized you are after going through IPC 144 and the functions and the things, how to organize them and package tasks that are related to each other in functions and modules and call them, when you're designing some complex systems, it becomes so overwhelming that you cannot trace your logic back. It becomes very difficult to organize your thoughts through a structured program. That's why for our brains to be able to work with what you have already developed or other people developed properly, you need to have the system designed in a way you see everything in the real world. And that's the target of object orientation. So what object orientation does is that it simulates real world in your application. Anything that you create. So instead of actually thinking of how am I supposed to do things, you first think how things are based on your need. And those we call objects, we call classes. And we said we put data and behavior together. Why? Because any object in real world, it has attributes, it has specifications, and it does something for you. Therefore, you design your system that way so it acts the same thing. So for example, if you have a menu in a restaurant that you're looking at it, if you want to design a system for that, you don't think of how am I supposed to list anything. The very first thing you think, I need to have a menu. So you create a class called menu. And then you look at your menu, see what does the menu have. It has menu items. Now, if the menu items that you have, they are separate things of their own with its own properties, you make that one a class of its own. So you're going to have a menu item class. The menu item class only focuses on one item that is displayed on menu. So you think about that. It has a title, it has a price, it has this and that. All the things that a menu item is supposed to have in a menu, you put it in that class. Then you do not think of a menu item as what you need to display. You have to think, okay, A menu item is visible, so it can be seen. Therefore, it's displayable. Therefore, your menu item can display itself. Your menu item can tell you what is its price. Your menu item can tell you what is its size. Like, for example, if you want to order like a drink, it's a menu item, right? You can have small, medium, large. So these are the aspects of a menu item. So you design everything in that one. Then after you're done with that, you try it. You see if a menu item by itself can show itself on a screen. When everything is fine, you set that thing aside. Now you completely forget about menu item. You only think about menu. Why? Because menu item is solved. It's done. Now your brain, your thoughts can be free, only thinking about how a menu works. Then you simply say, okay, menu item is a list of, a menu is a list of menu items. So all you need to do, you create an array of menu items and you put it in there. Do you care how to show every individual of them? No, you don't. It's not your responsibility. Menu item knows how to show itself. Then after that, you think of a menu. Okay, a menu that I have can display all the menu items inside. So for a menu item to show its menu items, all you need to do is to write a loop, go through menu items, and ask each menu item to display itself. You don't need to worry about how. So your menu items display is a repeated call to the display of menu items. Therefore, everything is displayed. Therefore, everything works. And like this, you can actually work in a team too. You're going to say, you're responsible to write the menu item with this specification. That's what system analyst does. System analyst designs everything, so looks at an object and sees what's going on. For example, take a look at this one. This is list of stuff, right, on a screen right now. These, if you look at them, they look very similar. Why? Because each one of them, it's a selectable item. So the person who designed only this thing, it knows it's going to have an icon at left. It knows it's going to have a title at the top and a description at the bottom. It's their responsibility to create that, not this big dialog box. This only. And over here, you have a file list, right? So for a file list, the person who's designed it, again, its responsibility is to show the value over here, an icon at left, a title, and a path. Don't these two things look similar? They do, right? That's inheritance. So they both have icons, as you see. They both have titles. They both have details, but it's different. So the parent of these two are the same thing, and that brings us to inheritance. So they designed it that way. So the person who's designing it says, for something to get displayed on a dialog box in this way, it's supposed to have an icon at left, it's supposed to have a title, it's supposed to have a description. Let's design that without going to details. Then the next person comes, says that they tell you the displayable item that you have inherited to a selection and a file list. So it becomes children of that. And after everything is done, then they write a dialog box that has lots of displayable stuff in it. So as you see, it goes like that. They don't think about this as, first I have to draw a rectangle. They don't do stuff like that. Each item knows how to handle its own property and its own actions. It's like, this is the programming part, but in real life, how do we do this? You own a restaurant. You need to serve people. What do? You hire servers, waiters, right? You hire waiters. There is a definition of what a waiter is and its responsibilities, right? You hire 4 of them, and you populate your restaurant with the 4 waiters. And then each waiter does its job. the way it's supposed to do. So essentially, your restaurant is a class that has waiters in it, it has chef in it, it has cook in it, it has manager in it. So all these things, and each one of these classes by themselves, they know how to work. You put them together and say shoo, and the restaurant starts working. That's what happens in real life, and that's how we try to do it in our system. So for our restaurant, if we want to go through the 3 pillars of object orientation, remember what I told you? If I see you smile at your screen, all the computer is going to be gone. I'm giving you a warning. I just saw someone. Please. Okay? Sorry, I get distracted very easily. Yeah, so for that restaurant thing that I was talking about, let's see what are the 3 pillars in that restaurant thingy we have. First of all, we have encapsulation, obviously, because each waiter has its own salary, each waiter has its own name, it has its own attributes, and each waiter knows how to work. So that's encapsulation. Where inheritance come from? Employees. So you have employees in your restaurant, and each employee has a salary, each employee has a name, employee ID, and an employee knows how to work. When you inherit an employee to a waiter and a cashier and a chef, then the employee that is a waiter has a method called work, the cashier has a method called work, and the chef and the cook has a method called work. When you ask a waiter to work, waiter waits. When you ask a cook to work, provides recipes, execute recipes. For a chef, when you say to work, it provides recipes for cooks. So each one, and for cashier to say work, it charges people with money and stuff. So each work does the work in a different way, and that's polymorphism. Encapsulation, inheritance, polymorphism, and we have a restaurant. Okay? We good? Now, what's abstraction? Abstraction says this is a Chinese restaurant. I'm not going to serve pasta in here because that's going to be in an Italian restaurant. That's the abstraction we are talking about. So which one is what? Or this is a hot table restaurant. This is a buffet. So each one has its own thing. So the abstraction of how things are done is different in restaurants, but they're all restaurants. We good? Okay, so let's start. So that's the need of object orientation and everything. So the very first thing as I do, as usual, as I told you, I'm going to do this a few times to create a project so I can actually have my notes in there. So again, here your section A, so I'm going to go to Notes, Section A, select Folder. I'm going to call the project B-January 9th, and always have this selected because our projects are not, we don't have multiple projects in a solution. We only have one project in one solution. So that's what we do. We click on Create, and it's going to create our project. To start, I right-click over here in Solution, Add New Item, call it prg.cpp. And I'm going to call include IO stream using namespace. And I promise that I'm going to. What is the extension of my program? PP. It's not supposed to be PP. It's supposed to be CPP. You cannot rename it. In old versions, I'm not going to try it, but when you rename, because when you write a source file in CPP, it decides it's a source file. If you, for example, renames a TXT file to CPP, it will not compile it because it still thinks it's a TXT. The safest way is to delete it and recreate one. But I'm going to try to see if they actually fixed it or not. It wasn't like that before. So I'm going to go CPP and we'll find out. Oh, it worked. OK, so This time it worked. Anyways, be careful. If you change the extension and you see it doesn't work, it means you have to completely remove it. Remove from the project and re-add it, not delete. So you right-click over here, you say remove, you remove it, and then you add it again with a proper type. Okay? So namespace, using namespace, std int main, return 0, always fill in the blank, complete the structure of what you're writing, and then fill it. Now I'm going to say in console output, insert OOP244 NAA, January 9th. N and L, Control F5, compiles and executes without debugging. I'm going to teach you how debugging is. Unable to start the program. The system could not find the file specified. This computer of mine needs to be updated, and I asked for it for a long time. Maybe let's see if that was the case. I'm going to add again. Let me see. We are add existing item. Looks good to me. Debug. Yeah, so see, remember what I told you? If you just rename it, so let me just run it one more time. Now it runs. So it did not fix, they did not fix it. Just don't rename it. Did you see I just renamed it, it didn't work when I compiled it, and I removed it, and I added it back as a source file, so be aware of that. Anyways, OOP244 NAA January 9th, so that's that, and I have it, so let's continue. Okay, so going back to the language you're learning, C++, contains C in it. There's just a little bit that is not covered in here. Don't worry about it. You're never going to have that, face that one. So C++ essentially, you know what plus plus is in C, right? What does plus plus do?
Implementation.
It adds 1, right?
Yes.
So plus plus adds 1. When you say C++, you're essentially, the meaning is C is C with an extra feature, which is object orientation. That's all. So that's why they called it C++, okay? So, yours now, my dear. And then please afterwards. What does C++ do? C language is very powerful, okay? Linux is written in C language. So C language is a very powerful language. And don't think that it's like obsolete. It's not. Many, many things are written in C language. And for years, you need to debug and you need to maintain them. So knowing it, don't think that your skill for C language is gone to waste, actually. But C language, it's a little too powerful in structured languages. It means allow you to do anything. You can have a pointer and print it as an integer with no problem. You can do that, okay? C++ prohibits that. It's called type safety. What C++ added, and another feature, that it's getting more strict as we go to higher versions. Now we have C++ 20, C++ 24, and so on and so forth. You are doing C++ 11. That's the standards that you have. It means 2011. Go figure, okay? But still, as we go, I think 14. I don't know, well, whatever. It's an old language, so everything works. Don't worry about it. What I'm saying is that in C++, you can still do what you have done in C, but you have to state your intention, which means, we'll teach you later how. But in C language, you can, as I said, you can print a pointer as an integer, and it shows the address of whatever the value is. But in here, in C++, if you do it, it gives you an error, unless you explicitly tell to C++, hey, I want to print this pointer as an integer. Then when you state that request, if a pointer is convertible to an integer, it will convert and show it to you. Okay, so still you can do anything you have done in C language, but you have to state your intentions. And if what you're stating, if the state of your intention is not what you're doing, the compiler will not allow you. That makes the language safer. Because all these things are hidden stuff that's going to cause trouble. Okay? Namespaces, a bit too early to talk about it. That's why we're jumping back and forth. If you look at it over here, we have modular programming, and now we have main namespaces over here. I'm going to jump right into modular programming now to explain to you what namespaces are. Because namespace is something without modular programming means nothing. Okay, so before doing something like that, before actually getting to this, what I'm going to do is tell you how compiler works. Did they teach that in C language, how the compiler works? Did you have anything, anybody ever talked about? So they mentioned how compiler compiles, not how does it work. Oh, yeah. So from what you're saying, I can actually tell that quickly mention to you what we have two types of. This is very old, but I'm going to tell you. We have two types of language. We have compilers and we have interpreters. Interpreter is like, have you seen in United Nations the guy is talking and somebody has a microphone and translate it just in time? Okay? It doesn't know what the entire speech is. So the person who actually interprets the thing doesn't know what the entire speech is. Line by line is translating what the speaker is saying. We good? We have such a thing. So like programming languages like Perl are like that. Essentially, when you write lines of code, what translates the language in machine language reads it line by line and executes it. Which means if you have an error at line 50 and you're at line 25, it keeps executing until it hits 50. And then poof, it's going to crash. So you see the program executes and it crashes. Compilers are not like that. Compilers read the whole story, make sure that it is executable. Now, it may execute incorrectly, but they compile the entire thing into an executable. Then you can throw away your source code, you can throw away the compiler. Get this executable and you can run it without existence of compiler and source code, where the interpreters are not working that way. For an interpreter to actually run your program, you need to have your source code present, you need to have your interpreter that is Perl present. And then this runs that. But when you are writing C#, when you are writing C++, when you are writing any language that has compiler, you're writing, yeah. So when you do that, what happens, it gets the entire code, compiles it, and runs it, okay? We used to say that interpreters are easier to debug because it runs a program and it crashes where it crashes. So essentially, it's always in a debugging mode, okay? Where compilers, you have to actually run it. If it hits a problem, you don't know where it happened. You actually have to write codes over there to print stuff to see what went wrong. Anyways, so be aware of that. But that's compiler interpreter. But how the compiler works? How compiler works is like this. So let's say, first of all, nobody writes a program in one file. It's like, seriously, nobody does that. Because when you write a program or an application, it has multiple programmers and multiple modules and multiple files. So you never have one file being compiled with the compiler. So when you are writing a program, you have multiple files. Each file, we call it a module. Each file that is being compiled, a translation unit they call it in OOP244. In 244 we call it a module. Each module separated on its own is a CPP file. So 1.cpp, and it has a header called 1.h. Okay? For a function to be called everywhere, what do we write for a function? So we can call it anywhere?
Can you repeat, please?
So when you write a function, if your function is under main, and you want to write a function, you have to write something at the top of the main. What do you call that? Do you remember?
Declaring the function.
Declaring, well, it's called the prototype, but you're right. Okay, declare and definition, yeah. Declaration is to write the prototype, absolutely right. And definition is to actually write the body of the function. So we call it prototype and function body. So you have to write the prototype at the top. All the prototype and declaration of your stuff go to the header file. The body of all the functions and things, how things are done, they go to CPP file. Okay? Did we have the SLG representative in this class? Nobody over here had the presentation that we are doing this and helping you and yada, yada, yada? No one? Not yet? Okay. So they're going to come. They did it in the other class. I didn't know which one was. Sorry about that. So let's say they come over here and say, ladies and gentlemen, help is provided to you. We're going to have tutors down in the Learning Common helping you with OOP244. So you can study with more help and you're going to be more successful. Everybody's going to be happy, correct? This is a compiler compiling and giving you a thumbs up that the code compiled properly, which means you're going to require a tutor one day, and I'm telling you that the tutors are down there. That's when you are writing the first module or second module or third module. So as you see in the third module, 3.cpp, I am including 2.cpp. You see I put the red thing over there, which means 3.cpp is using the tutors in 2.cpp. Okay? So when I compile 3.cpp in this header file, I'm telling that the tutors are there and go do whatever you want to do. So 3.cpp, it's happy and it compiles properly, and the code for it will be generated. Okay? So as a result, anytime you are actually compiling a project, as you see G++, 1.cpp, 2.cpp, 3.cpp, and main.cpp, and enter. When you do that, the compiler actually runs four times. That was a syntax error. 4 times, okay? Which means first 1.cpp is compiled. It makes sure all the syntax and everything is correct. This is created, then 2, then 3, and then 4, and you have these 4 done, and everything is good. Right? Down to this point. Now, you have a problem with your project. You go down to Learning Common, and you see there is no tutor. But you were promised. The compiler compiled things properly. But when you are going down to the Learning Common, there is no tutor. What does it mean? It means you had the prototype for the tutor, but you couldn't find the body of the tutor. You had the declaration of the tutor, but you didn't have the definition of tutor in Learning Common, which means in 3.cpp you mentioned I want something from 2.cpp, but when it wants to run, it's not there. That running happens with the fourth program called linker. It's not running actually, linker prepares it. So this linker, that is the 5th program that is being running, or 5th execution over here, guarantees that the promises you made are kept in other files. Which means actually goes downstairs in Learning Common, looks, is there a tutor? Yes, so we're good. Now you can study. Okay? So after linker is done, your executable is created, and that's when your program actually runs. Logically correct or incorrect, it's remained to be seen. But it will run. We good? Okay. So that's how compiler works. Each thing that you're writing, we call it a module. Are we okay with this? Right? Now, how do we write modules? I'm going to give you an example for a module over here and tell you how the modules are, and I'm going to go through some definitions for you with it. So There are basic things that you need to do is to prepare your module to code in it. Those things are common between all modules. You must memorize it, and you should do it with your muscle memory, which means you should not think when you're doing it. There is no logic behind it. There is logic behind it, but it's common in all the modules you're going to write in your life. So you learn it once, and you apply it to everything. Be good? So, what are namespaces? Let's say I am creating a class called student. Okay? I want to create a class called student. Did we talk about abstraction? Okay. What was abstraction? Abstraction was, could you please pass the, you already answered something, didn't you? So pass it to the gentleman over there.
In the past session.
Huh?
In the past session.
Oh, okay, okay. So, no. Today, did you do? Okay, good. So it's your turn. Put the microphone towards you. So the fluffy side. Ah, there we go. Thank you. Okay, so do you remember what abstraction was?
Removing extra data.
Removing extra data. Removing what is not needed. So it becomes possible to write code. When you think about it, actually, after a while, when you become an experienced programmer, it becomes a challenge. Because as a programmer, you see everything that an object has. And you are tempted to implement everything. But they are not needed. You need to know what the business logic requires. And that was abstraction. So, talking about a student. If you are in education department of Seneca, what is a student for you? A student is a person with name. A student is with name, student number, GPA, number of semesters that the person is in, number of courses taken, number of courses currently, number of courses passed, with what mark, number of courses taken now, right? These are the things that education department wants to see about a student, right? But let's say you are not in the education department. You're in administration, or let's say you're in OSAP department. Everybody knows what OSAP is, right? I guess everybody knows what. So what OSAP wants to know about a student? Name, student number, balance of their loan, maybe they need the GPA, monthly payments, things like that. So it has nothing to do with education. Some similarities between the two, but the abstraction of the OSAP department is different with the education department. But we are both programming in Seneca, right? So if I create a student, which department gets to choose what is the name of the class? If I have a struct student in the OSAP department, what should the education department call its class? Struct what? It's still a student, so there's a naming conflict. Because of that, we have what we call a namespace. What is a namespace? We're going to come back to this soon, and modules and everything. But what is a namespace? A namespace is essentially a space you create in which you will actually put all the code related to that namespace. So you will have a namespace OSAP. You see, I'm not using anything, I'm creating it. In here, you create struct student with whatever a student needs for OSAP. And then in another department, in another module, I'm putting everything in one file, but in reality, different modules have different namespaces, okay? So what happens over here is that the education department writes a namespace, and in that namespace, let's say EDU for education, they create a struct student. Now, in here, there may have a struct loan. That is the loan that the student's supposed to take. And in the education, we might have a struct subject, which is the subjects as students are taking. So as you see, not necessarily namespaces, they all have the same classes. They have classes that are different, but some of them are common. You understand that? Okay. Now, I'm going to put this namespace at the top so we can actually see. Actually, first let's save this as, what do I call it? 01, welcome. Yeah, welcome. Okay. I'm going to put it at the top over here. It's just for teaching purposes. This never happens in reality. Okay? I'm just showing you syntax. Now, in here, if I want to create, an OSAP student, I have to write over here OSAP scope resolution, which means literally what it says, scope resolution. It resolutes the scope, which means it says, go to OSAP and tell me what is available. You see, I have loan and student now. So I can create a student. OS, okay? And now I can write over here edu, student, and I have ES. So these two can be created with no conflict. So what is using and what is STD? Namespace wasn't originally in C++. We didn't have such a thing. But then they found out the problem. They said, okay, we cannot do this. We are short in names. And because of the different type of abstractions that we have, we need to have the same object to be created in different ways. So what do? We're going to create namespaces. Then they said, so what are we going to do with all this stuff that already comes with the language? They said, we're going to put that in a namespace called STD. So that's why if you do not put over here using namespace STD, then like any namespace, any object that is in there, you have to qualify. You have to say STD scope resolution cout and STD scope resolution and L. Otherwise, it won't be able to find it. Got it? So what's the difference between a namespace and a structure? The difference is that I can have, for example, something like this. As you see, I have OSAP student up there and OSAP loan down here. There is no problem. When you have two namespaces with the same name, unlike structures, they merge and form a bigger one. It's like two bubbles joining, boop, they become a bigger bubble. It's exactly like that. So namespaces don't conflict, they merge. Custom types, which are subjects, structures that we create, if they have the same name, they will not. Okay? Now, another thing, and the last thing that I want to mention to you, what if I say over here using namespace OSAP? If your program is primarily to work with OSAP, you use the namespace with OSAP. So when you just say student, it will understand that it's for OSAP. It's not going to cause any trouble. When you don't mention anything, it's going to use that one. The question is, what happens if I say I'm working for Seneca, therefore I want to use both of them to see if the student is eligible for OSAP with his student records. Now I have to qualify for those things that are common. But things that are not common, I can use both. So loan and subject. Oh, look at my subject, subject. Okay. And I can say over here subject S. So as you see, the common ones must be qualified, but non-common ones can be used. So you can use multiple namespaces. And that's the end of namespaces. We good with this? So now that we know what namespaces are, we're going to go build our modules and see how our modules are made. That's why I had to go back and forth. Okay, we should have had namespaces at the end of modules. Yes? Wait. First of all, it gives you time to form your question, and also we can actually hear what you're saying. Go ahead.
So how do you stop using a namespace? Like you're
No, you
using it
can't.
there, and
You
then
can't. You
have
can't.
to make a new file. Like say you want to use a namespace in part of the program.
You cannot unuse it. When you use it afterwards, it's done. It's going to be used.
For the entire program.
For the entire file.
File, okay.
So thank you. So that using namespaces only works in prg.cpp, not in other files. Okay. And that's usually the case. You don't want to keep using and unusing. Okay? Using can be used in using that statement has many features that you're going to learn in 3, 4, 5, but baby steps. For now, we're going to just learn this. Okay? You can use part of things in a namespace. So you're saying, I only want to use the student in here and not the rest of the thing. So you can actually say using namespace OSAP student.
No, like I meant like
so
using
you cannot stop using it,
like
but you can limit the parts
OSAP
you want to use. Pardon me?
Like if you only want to use it, say like in the main, but then you don't want to use it.
No,
in
you
the
can't.
function,
Then you
go-
write 2 different modules.
Okay.
Yeah, you write 2 different modules. So how do we write our modules? So let's save this. What is this? So 0, 2. It's a good idea to watch if you have time. I know you don't have time, you have 6 subjects, right? So if you have time, it's a good idea if you see something is like extra time, like you can't fall asleep, you just want to, as you see, I'm putting everybody to sleep now. If you want to sleep at night, it's a good idea to watch other sections session, because the way things are taught, depending on what students ask, is different, okay? They're all listed over there, and they're going to be on YouTube playlists, so you know exactly what it is. Anyways, so I'm going to come back over here. Okay, how do we create a module? When you create a module always has a header file, and it has a CPP file, except with main. We good now to this point? We good? So as a student in Seneca, you write all your codes in Seneca namespace, which means any code you write will be in Seneca namespace, okay? And in your mains, you use Seneca namespace, okay? So it's always like that. Your modules are entirely in a namespace called Seneca. So what should I create? Let's do the student thing, okay? So let's say I have a student over here. Add. So this is what we are doing. I am working at Seneca College, writing under namespace Seneca, and I want to design a module for a student. These are the information you need, nothing else to do a module. Remember, I'm teaching you how to write an empty module to start developing in it. So no thought goes through this other than the name of the module. Are we okay? Okay. Now I'm going to give you other examples. So I am creating a student for Seneca. Therefore, over here, I'm going to add a new item, which is a header file. And in here, I'm going to call it student. So the name of the module relates with the class that is implementing in C++. Again, I say class because from now on, we're going to learn how to write classes. Not in a couple of weeks, in a week or two, but just be aware. So the focus of the module is the name, which in our case, usually it will be classes. So in here, I'm going to have a header file I'm going to create. Header file creates a pragma once over there. Pragma once is something C++y, but we don't use that. We use our own thing. So the very first thing you do, you create what we call a compilation safeguard. Probably you already done that in IPC 144, but I'm going to tell you how it's done here. So you write hashtag if not defined. Then in here you write the name of the namespace. The name of the namespace is Seneca, all capital, Seneca, underline. Then you write the name of the header file, student underline H. Okay? That's a rule. There is no compile error if you write something else. But that is the rule we are following at Seneca College. It's a policy you have to follow. First, you write this. Then, do not repeat typing it. Copy and paste it, because if you have a typo in this statement that you have written, your program won't work properly. So copy that and paste it underneath. Then change the second line over here to define. What we call this compilation safeguards. Safeguard, okay? That's number one. So that's the first thing you write, and you write it for everything. Now, question. If I told you to create a class, a module called table, in a namespace called HTML, what would the safeguard be? The safeguard will be, if not defined, HTML underline table underline H. Got it? So any namespace that you have, that comes at the beginning, then the name of the header file, then underline H. That's the rule. That's our policy. And that's going to be your question in the quiz. I'm going to ask you, you are working for a company that makes ships, okay? Now, you create a class for a cruiser in a namespace called Mitsubishi. What does it mean? You have to write, if not defined, Mitsubishi underline cruiser underline H. Done. Got it? Is that clear for everyone? Okay. After doing this, then you actually create the namespace. So you write namespace Seneca, all lowercase. That's your empty header file ready to be filled with code. Done. Next, so you save this. Next, you create a CPP file for it. That's a C++. Student.cpp. And in that one, you will say include student.h and namespace Seneca. Done. This is an empty module. Now you can start thinking. All this should be done through muscle memory. Ta, 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 ta. Done. Got it? We good? All right. And then in your main, you will write include student.h using namespace Seneca. And this is the unit test for student module. Oh. Got it? So the main that is supposed to test or run whatever you have in student, it's written this way. So you use Seneca and you're done. So this is the entire module with this tester. Are we good? Okay, so that's just the regulation for it. So essentially, in this picture that I had for the compilers, each one of these things, this one is going to be the header file over here. Essentially, is going to be, if not defined, Seneca underline 1 underline H. That's going to be the safeguard for it, and it's going to be like that. And main is going to be using Seneca for all these three. This is the same thing. This is Seneca underline 2.h. This is Seneca underline 3.h. And because the name of the files are unique on the hard drive, it is impossible for that safeguard to be repeated. Now, what is the safeguard for? Why we are actually adding that? My thing is, give me a second. Okay. All right. So why are we actually writing these safeguards? Hashtag, when you start a line with hashtag, that's not C language. That's not C++ language. That's C or C++'s compiler language. It has nothing to do with C language. So when you start something with hashtag, you are talking to the compiler, asking the compiler to do something before compilation. So you are preparing compiler to do the compilation by writing a hashtag. For example, when you write include, it's literally a copy and paste. When you write hashtag include something, you are telling to the compiler to go copy the content of that file and paste it where you see the include, and then remove the include. So every hashtag include will expand to the content of that file. That's as easy as that. Be good? So remember you wrote define in C language? What did you write the define for? To replace something, right? So a hashtag define, it's literally a search and replace in that file. You're saying search for this item and replace it with this before you start compilation. Now, we are kind of abusing that thing or using that define thingy, okay? So when you define something, you can always ask the compiler if that thing is defined or not, okay? So in define Seneca student underline H defines it to nothing. But it's not important for me. For me, it's just important for that thing to be defined as a flag. So then what happens? You include student header file. And because it's including, 5 different places include might happen. And especially, you might, by mistake, not by mistake, unintentionally include it several times. Take a look. Main is using 2.cpp. 3 is using 2.cpp, correct? So when main includes 2.cpp, the header file of 2.cpp is included. But when it's included 3.cpp, without knowing, it is including 2.cpp too. Therefore, 2.cpp is included twice. That's syntax error. How do we fix that? This is how we fix it. We say, hey, start compiling. So the first time compiler hits it, it says, is Seneca student H defined? No. So keep compiling. It compiles everything. The very first thing that it does, it defines it and keeps going to the end. This is the first time it's been compiled. Everything is compiled and translated to code. We're good. The second time it's being compiled, it says, if not defined, but it's already defined. So it skips the whole thing and will not compile it. This is why we call it compilation safeguard. It guarantees that a header file only gets compiled once. Got it? We're going to go in detail of all these things in OOP244, how actually we write multi-platform stuff too. So yeah, you'll see. Okay? We got down to this point? All right. Whew. What's the time? 9:11. The class ends at 45. Okay, so this is the end of what we're going to do today. Now, I hope you're not too attached to the computers that you have, because they're all got to get reset now. All. Okay, so log back into your computers. Now it's the quiz time. Okay? Okay, so in real, this quiz is just, you know what it is, right? If you haven't done the agreement, let me know. Is there anyone over here who haven't done the agreement? You all did the agreement? One person does like this. How do you know everybody did that? Maybe she didn't do it. Okay, so if you have done the agreement, you're fine. You log in. Now you will notice the computers are logged in a different way now, which means you cannot go on Start button and look for something. You cannot type a URL in a browser. It won't bring it up anymore. Okay? So you have to literally click on the icon of Chrome to open Chrome to go to. So I'm going to do it actually over here for you. So this is what you're going to do. So you open up Chrome, and when you open Chrome, it brings up something like this probably, I don't know. It probably brings up something like this, okay? Then I'm going to go to Employee, but you're going to go to Seneca, or whatever. Through clicking, you're going to go to Learn, Seneca Learn, okay? And you open it up. So I'm going to go over here, and I'm going to go to Learn, okay? And I'm going to go to OOP244 NAA. I think I didn't do my, so I have to do it. Student Preview. So NAA. Let me see if I don't think I have done it. So I'm going to quickly do my practice thingy. Start attempt 1. Start attempt 1. Let's assume I read all that thing and I know what's going on. I'm just going to write some garbage in here. And I say I agree. Yes?
I can access the blackboard.
You're typing it. I told you not to type anything. Close it. Open. Edge. Click on Learn. Now you're in Blackboard. Okay? You cannot type URLs. Remember. Okay? So submit this. Okay, close. Okay. Now I'm done over here. Now I'm going to go back. And this time I'm going to actually open the quiz. So seriously, open the quiz. NAA. And I put it at right-hand side. Okay? Then you use My Apps to open Apps and open Notepad++. If My Apps tells you, set the browser to default, say no. But if any other question, check mark and say yes. You start the it's okay. So I'll do like this. When you open it, it's going to be like this. Make sure you put this one at left, side by side. Don't open it over each other. The very first thing you do, you save this as .cpp. So save your file as .cpp. Save as. Whatever, it doesn't matter. Garbage.cpp. All you need is a .cpp. You save, and you're ready to write the code at left. Now you can start your quiz at right. It gave me a grade? Did I do it already? Huh. 1 attempt. How do I do this? It says 1 attempt left. Do you have something? Oh, it's past due? Oh my God, let me fix it. My apologies. You have the same thing? It says past due for you? I'll fix it in 2 seconds. My apologies, my apologies. So get off the quiz. Close the quiz only. Close the quiz, because if I change it, it won't apply unless you load it again. Close the quiz. The heck? Quizzes. Close the quiz. I'll tell you when to open it. Now you can open it. This is the code for the quiz to start. Okay? But in real tests, I'll mention it to you, you write it, and I immediately change it. Okay? Okay, now I can actually go back and restart the quiz. So this goes at right. This goes at left. I start the quiz. Oh, need the code. So if you see it's like this and it's small, don't make it big. Hold the control key and use the mouse wheel and zoom up. It disappears it and makes it as 1. Now at right side, 1 by 1, you're going to write the question. So you're going to essentially do this. Start coding like this. So question 1, you're writing question 1 and answer the question for it. First, you're just writing a code snippet. There's no function. And then question 2. So code snippet, it says write a C code. So I'm going to write over here for integer I set to 0, I less than 34, and I plus plus. And close it, and then go up, and whatever. Okay? Oh. We're all good, right? All right. Now, this is what I want you to pay attention for. I'm just going to do one thing, and then you're done. You can continue. This is where you are supposed to submit your code. Okay? So as soon as you feel comfortable that you have written something, do a Control A and copy everything. What's wrong over there? You need help? Do you need help? Do you need help? No?
No, I'm good.
Okay. So copy. Okay, you copy. Then you click on 3 dots. And then I'll come to you. And then you paste. And it pastes everything in here. Then you go back and you continue. Question 2. So the next time you want to put over here, you again select everything, Control A, you copy everything, and you go Control A and Control V, you paste everything, and it adds it, and it keeps expanding. Okay? So you just copy everything, and paste over it. It just expands it. So you keep going like that, and you complete the question. Make sure when you're close to end, you copy everything. You don't have to do it at the beginning, but you copy it, because if you don't do it at the end, it auto-submits and everything goes down the drain. Yes, sir? My apps. Everything is clickable. Okay, so you have to click and write your ID. Please watch the video of that agreement one more time. The next time you're doing quiz, I'm not going to handhold. Okay? There's a reason that agreement has a video for you to see how things work. Click. Yes. Just look at the number at the top. 098. Okay? And by the way, this quiz falls under the category of plagiarism too. If you answer someone else's version, it will be filed as plagiarism. Although I'm asking you, you just attempt to write the answer, you will get the full mark. Okay? So don't copy from your friend beside you. Careful. If you cheat, it will be plagiarism over here, even for this. Okay? I want to know what is your knowledge, not your friends. Okay? And the versions of the questions are most likely different with what you have beside you. Anyway, so good luck. If you need any help, let me know. You good? The one thing you need. Did you save this as C++? File, save as. Type CPP. That's better. Keep going. And if you are a student with accommodation, your quizzes will be done in test center, not here. So you have extra time.